We are continuing in section 1.2. Last time we did the overview of the real number system. In this video, we're going to take a look at reviewing and defining some inequalities and absolute value, and we'll probably get into some translating problems at the end as well. So let's go ahead and jump in here and begin with just reviewing our inequality symbols. So you probably remember your inequality symbols. The symbol that means is greater than is this symbol. The symbol that means is less than opens in the other direction. Now notice in my phrasing here, this is important for translate problems. So there's an is with it. So when you say is greater than, it means the inequality symbol. When you see is less than, that's going to mean this inequality symbol. Whereas we'll contrast this later with if I only had the phrase something less than something else, that would indicate subtraction. Okay, so that's kind of a separate thing to keep in the back of your mind there. All right, now if you throw in the or equal to with that, that is going to be indicated by a line underneath the appropriate inequality symbol here. So is greater than or equal to, and then is less than or equal to. So those are our inequality symbols. I'm going to rewrite that one actually. And so what a lot of you probably remember the most is kind of how to evaluate problems in terms of using those inequalities. You probably remember this notion of like the mouth of the inequality opens out towards like the larger quantity, and that's fine, that's good to remember that, but you also want to just know the language that if it's in a sentence, which symbol it's referring to. So when you see these ones that involve the or equal to, so these literally mean, so let's just kind of write something here off to the side. So this means that it can satisfy either the greater than part can be satisfied or the equals part could be satisfied. So when you have greater than or equal, it means either of those could be satisfied and you'd have like a true statement. It could either be greater than or it could be equal to. And like on the second one here, when we have the less than or equal to is how we even say that. The statement could satisfy the inequality. It could be a less than situation, and that would satisfy it. Or it could be equality. So if it's equals, it would also satisfy it in some sort of statement. So that's what those mean. All right, one more definition to recall. And again, kind of on just like with inequalities, I bet you know how to use them maybe better than you remembered if you just saw the vocabulary, which one it was referring to. Kind of the same thing here. My guess is a lot of you remember something about the notion of taking the positive of something. You probably remember this idea. Like if I gave you, I'm going to throw something down here within this first example. Suppose I just gave you the absolute value of negative 2/3 down here. You know, my guess is that a great many of you remember, oh yeah, I know absolute value. I'm just supposed to take the positive of what's on the inside, right? Well, that's how we evaluate it. And even that, there's a lot of conditions that go along with that. And we're going to get more specific about that in just a second. But like, what's its definition? Like, why am I doing that? And that goes back to its definition. So the definition of absolute value is it is the distance. So it is the distance, and that's pretty key, from or between, I could say. As a matter of fact, I think I like the word between better. Let me erase my word from here. So let's say it's the distance between 0 and this number a that's on the inside of that. So this is why you kind of remember this notion of taking the positive on the inside. So let's just kind of put this in parentheses. So this is why to evaluate, which is really a different idea than the definition, the first thing you're going to have to do, and this is a very crucial and important part, is you're going to need to simplify, this is really key, the inside of the absolute value bars first. You need to get it down to like one number on the inside first. And then it's this part that you're more familiar with, kind of the second step. If we're already down to one number, like in the example I have below, this is where you kind of have this notion then of taking the positive. And of course, the reason for that is distance always has to be a positive measure. If I said, what's the distance from your house to ECC? Well, that's the same thing as if I say, what's the distance from ECC to your house? You wouldn't ever say, well, which direction do you want me to go? Because I'm going to give one of those negative. Like, you wouldn't say that. So you intuitively have this idea that distance is something that needs to be a positive measure. And so that's why we do that when we evaluate absolute value. All right, so in this example down below, I already started to write out this problem, but we are going to evaluate, and so the left-hand side is this absolute value of negative 2/3, and then the right-hand side, I'm going to give us the absolute value of negative square root of 2. And then what I want us to do, we need to think about evaluating each of those in a form that we can make the comparison, because I want us to fill in all of the symbols that apply or that make a true statement. All right, so this 2/3, I hope that you know is, and these are some of the examples that we used in the last video. So 1/3 is 0.3 repeated on and on forever. And 2/3, of course, is this 0.6 repeated, 0.666 on and on forever. Now, over here on the right-hand side, again, it's already simplified down to one number. So when I take the absolute value, I'll drop the absolute value bars and I will have positive square root of 2. Well, again, in order to make a comparison, I would need to think about it in its decimal form. And again, if you just went to a calculator, this would be approximately 1.41 ... I'm going to say, because I don't remember those off the top of my head, but that's enough to make a comparison anyway. So now we are comparing. So as we look and we make this comparison here, so we are comparing this, negative, or I'm sorry, it's positive. We're comparing this 0.6 repeated with this approximately 1.41. So those are the two numbers now that we can focus on and compare. So we want to go through the list of these symbols and fill in any of them that make a true statement. All right, so certainly 0.6 is less than 1.4. Okay, so 0.6 repeated less than 1.4, with its going on forever with no pattern. But so certainly the less than symbol is true. Well, guess what? If the less than symbol is true, then the less than or equal to symbol must also be true, because it satisfies the less than part. It just has to satisfy one or the other, and it already satisfied the less than part. And then the last one that's also true is that these two aren't equal to each other. So not equal would be a third symbol that would make a true statement. All right. So let's look at another example. Okay, so again, we're going to do kind of the same thing here. We're going to have a couple of sides to this little expression here, and then we're going to do just a little bit of maybe simplifying each side, evaluating, and then we're going to fill in all the symbols that would make this expression true. So let's go ahead and take a look at, we have a minus and then absolute value of a -3. And then I'm going to fill in, again, any statements, inequalities, or of the above symbols, I should say, that make it true. And then the right-hand side, we're just going to have -pi. So here's something on the left-hand side as we evaluate this I want you to be careful of. So you need to, first, if there was anything to simplify inside the absolute value bars, you would. There's not. So we're going to be able to first just evaluate that absolute value. So this is crucial. What you can't do here first is multiply or think about, thinking of these two negatives, like the opposite of negative is positive. That is certainly true in a situation if there was no absolute value bars. But with the absolute value bars, you must simplify, kind of start in and work your way out. That's a good order of operations idea to be mindful of. So first we take that absolute value, and this minus is just kind of out in front getting carried along. So that minus, got a little bit sloppy there, is just out in front getting carried along. Okay, so what we have on the left-hand side here that we're going to be comparing is we have this negative 3 over here on the left-hand side. Now, on the right-hand side, there wasn't any absolute value this time. It's just negative pi. So we need to think of that as like its decimal form, at least a little bit, negative 3.14, and obviously it goes on and on forever. So these are the two numbers that we want to compare. So sometimes when you start to get into some negative numbers, it starts to maybe just get a little more difficult. And so a good tool here for you, I think, is just to think about where these would be on the number line. So suppose I was to think about over here, maybe graphing these two numbers. So suppose I have a number line, and maybe we'll say this is 0, and then we have -1, -2, -3, -4, and so on. So here's -4, -3, -2, -1. Okay, so just a pretty basic number line here. Okay, so first I have this number -3. So here is my -3 right here. And then I have negative pi, -3.1. So it's going to be, and I made that dot so darn big, I'm going to go back and make that a little bit smaller. So here's where my -3 is. And then just to the left of that is this, obviously not drawn to scale. So this is going to be my negative pi, because this is that -3.1. It's a little bit further to the left. So when it's further to the left, that means it's less than the number that's to the right of it. Right numbers are bigger than left numbers, let's say. So this means that the -3 is to the right of negative pi. So the -3 is actually bigger than the negative pi. So -3 is bigger than negative pi. Well, again, guess what? That means it's also bigger than or equal to, because it's already satisfied the bigger than or the greater than part. So it will certainly satisfy the or equal to. And so I'm just going to rewrite those. So we have greater than or equal to, and once again, we also have our not equal. Those two are not the same numbers. All right, so next time we'll come back, we'll wrap up section 1.2 here by looking at a few more examples, a translating example, and then also just a little true-false example. So we'll wrap that up in the next video.